So here's some stuff about radicals and roots. Square root of A equals B. Let's take that, and what does that mean? That means that B squared equals A. So the square root of A equals B. That means B squared equals A. It also means that B is going to be greater than or equal to 0. So what else can we learn about radicals and roots? Let's see. We could say we talk about the principal nth root. So let's say that you have a root n of A equals B. Yeah, let's separate this two, right? This is two different things, two different ideas now. So that means the same thing. I mean, we basically saw that. It just means that B to the n equals A. Alright? If we know that A is even, or if we know that n is even, if n even, then A is going to be greater than or equal to 0, and B is going to be greater than or equal to 0. That's because basically you can have a negative, you know, but the root of it, if you had, you know, let's make it really clear. See, basically, let's say you had the fourth root of 81. Well, what times itself is 81? That's 9. And then 9, so let's make sure we understand this. 9 times 9 equals 81, and 3 times 3 equals 9. So this, you know, fourth root of 81 is going to equal 3. Oh, it's going to equal 3. Alright. Another way to write that is 3 to the fourth is 81, right? The other one that we were looking at. N root of A equals B. Well, B to the n equals A. We also know that 3 is going to be greater than or equal to 0. So let's try this. Let's try a cube root of -8 equals -2. And we're going to know that's so because -2 to the third equals -8. Let's see here. So I guess we should look at some properties of roots. Properties of nth roots. Let's see here. How about fix my glasses. Let's say that we've got the nth root of AB is going to equal nth root of A times the nth root of B. And a nice example of that will be the cube root of -8 times 27 make sure that that extends over here, will equal the cube root of -8 times the cube root of 27. You see that? There it is. Cube root of -8 times the cube root of 27, which we know will equal -2 times 3, and then we know that that will equal -6. Let's see, another property will be that the cube root of n, or nth root, excuse me, nth root of a over b will be the same as the nth root of a over the nth root of b. And that will look like this. You'll say how about the fourth root of 16 over 81? And that will look like the fourth root of 16 over the fourth root of 81, which will look like 2 over 3. Let's see, how about the m root of the nth root of a? You can have something like that happen. Well, that's going to look like this. You're just going to take you're going to multiply these roots, and then you'll have a. So that's nice and easy. Let's say that you had the square root of the cube root of, I don't know, pick 729. Well, then that's going to be the sixth root of 729, and that happens to be 3. I'll just tell you, it happens to be 3. So, how about if you had the nth root times a to the n? Well, that is going to equal a if n is odd. And now an example of that is cube root of -5 to the third just equals -5. Or you could do it, you know, the other direction. I mean, if it didn't have, if a was not odd, then, like, let's say you had the fifth root of 2 to the fifth, that's just going to be 2. So, no, that's if your n is odd. That's if your n is odd. What about if your n is even? So let's say you've got the n root of a to the n. That's going to equal the absolute value of a if n is even. So that'll look like this. You'll have fourth root of negative 3 to the fourth. That will equal absolute value of negative 3, which is 3. Okay, so what about rational exponents? What if we had to do something like this? A to the m over n. Well, that equals the n root of a times m. So you can basically just take this is important to just note how you move these things around. Okay, you can write it like, you can take this a to the m over n. So move your denominator n as the root, and then multiply by your numerator. We could also do something like, we could also make it look like this. You could say the n root of a times m. So that's just one you gotta kind of stick in your head. Alright, there's your roots and radicals and stuff.